Welcome to Maths with EJD. In this video, I continue with trigonometry and I get to talk about sum and difference formulas. They are very important in trigonometry and we just go straight into it, talking about certain basic sum and difference formulas in trig. First of all, we can talk about sine, the sign of sums. So we have sine A plus B, for instance, and that is equal to sine A cos B plus cos A sine B. So it means that if you're taking the sine of the sum of A and B, it is the same thing as it can be expressed as sine A cos B plus cos A sine B. So there are situations where we need either of these expressions to do what we have to do. Of course, these things have proofs, but I won't bother about the proofs. I'll just write the sum and difference formulas and show some applications of this. Okay, then we can have sine A minus B. In this case, it just goes straight to its sine A cos B minus cos A sine B. Okay, now things get trickier when you get to cos. Look at what happens with cos. So when you have cos A plus B. It is simple in that the first combination is cos cos. So you have cos A cos B. But then when you have plus, then here it becomes sine A, sine B. Then if you have cos A minus B, then again you have cos A, cos B. Then the minus, since you have minus, and then here you have plus sine A, sine B. And then lastly, you can talk about tan A plus B. Now, already we have established that tan is always the division of sine and cos. So based on that, we can do this. You have tan, okay, you have tan okay, control Y there. Okay, good. So now you have tan A plus B. Of course, I can write it straight, but I'll rather go through the process of showing how we can derive that by saying this is sine A plus B over cos A plus B. So we've established it several times that sine over cos is tan. So in this case, you know sine A plus B is sine A cos B plus cos A sine B. And that is over. Cos A plus B now is cos A cos B, now minus sine A sine B. So there are different ways of expressing this finally, but then you want to go the way of making everything into tan as much as possible. And the way to do that is to divide by this expression, cos A cos B. That is the only one that will guarantee you having at least a constant number or tan somewhere. So then we go ahead and say this is sine A cos B divided by cos A cos B. Then here you have plus cos A sine B divided by cos A cos B. And down here, you have cos A cos B divided by itself, cos A cos B. So we chose cos because we know we are guaranteed having cos under cos as denominator anywhere. So that way we know that the worst that will happen is cos can cancel cos. And then when we have sine over cos, we can get tan. So this is cos A, cos B again. So if we go through this now, we have sine A over cos A of sine A over cos A is tan A. It's clear that cos B and cos B will go. Then cos A and cos A will go. And sine A over cos B, sine B over cos B is tan B. Of course, it becomes something very beautiful. Cos A cancels cos A, cos B cancels cos B. So all of that is 1 minus sine A over sine B. So, sine A over cos A, that is tan A. Sine B over cos B, that is tan B. Okay? So finally, you discover that tan A plus B is the same thing as tan A plus tan B over 1 minus tan A tan B. Okay? And lastly, of course, if you do the difference, you have tan A minus B. Tan A minus B. Of course, you could go through the same process, but all you're just going to get is sine A minus B, sine A minus B over cos A minus B. All right. So, and what that is simply just going to give you is that, is this, you're going to get tan A minus tan B all over 1 plus tan A tan B. So the signs just change. So these are the formulas. So it's very important to know all these formulas. And now the question is, what do you do with these things now that they are all spelled out? What do you do with them? So let's take questions. Let's take questions. Now, all the things you have done in the past, this whole idea of special angles, that you do not even need to punch a calculator to get their values. Like, you can even get the answers and the values in third form. So all of this thing can become very useful at this point. So for instance, let's take an example. Let's take a first example. Say example one. Example one. Um, you want to, so the question is something, okay, here now we just go, we say to calculate sine 15 degrees. You want to calculate sine 15 degrees given given that okay, this is even given. So given that sine 45 degrees is equal to cos 45 degrees, and that is equal to 1 over root 2. We derived all of this when we were doing when we talked about special angles in one of the previous videos. So we want to calculate sine 15 degrees, given that sine 45 degrees equals 45 cos 45 degrees, which is 1 over root 2, and cos and cos 30 degrees. We did this two. Cos 30 degrees is root 3 over 2. So, I mean, this is just to tell you that we want to find sine 15 degrees using 45 and 30. So normally what the instinct you have, the normal instinct is when you see sine 15 degrees, you pick your calculator and punch it. But here, if you are given the question this way, it means the answer should come in some kind of, in a short form too. We don't want decimals, or if you want decimals, that's all, want to arrive at that, going through the route of using all these expressions you have been given for these special angles. So that is why we had to do special angles in the first place. Okay, so to answer this now, let's go this way. So we need sine 15 degrees. And you want sine 15 degrees to be a combination of 45 and 30. So that can be actually sine 45 minus 30 degrees. 45 minus 30 is 15. And based on what you already know from the principle that sine A minus B, like you saw ahead, sine A minus B is sine A cos B minus cos A sine B. So this means that this is sine 45 degrees cos 30 degrees minus cos 45 degrees, then sine 30 degrees. So with that, these things you have now make sense now. So, cos 45 degrees is 1 over root 2. And cos 30 degrees, like you already have, cos 30 degrees, okay, of course, up here we still have sine 30. Sine 30 degrees, right, is 1 over 2. Even if you're not given that, right, from the idea of special angles, you should get that out. Okay, so sine 45 degrees is 1 over root 2. Cos 30 degrees is root 3 over 2 minus cos 45 degrees, that's 1 over root 2. And sine 30 degrees, that is 1 over 2. So we have that way. And then this is root 3 divided by 2 root 2. 1 times root 3, root 2 times 2, that's 2 root 2. Minus 1 times 1 is 1, all over 2 root 2. Okay? And then you can actually take the LCM, which is 2 root 2. And then, of course, that's simply root 3 minus 1. Of course, to make things tidier, you want to multiply, you want to rationalize. To rationalize it is to say root 3 minus 1 all over 2 root 2 times root 2 all over root 2, you know. So you can go that way. And this simply means that you have root 3, or better still, you have root 2 into root 3 minus 1 all over 2 root 2 times root 2. That is 2 root 4, if you like. That's how to look at that. And of course, that is root 3 times root 3. Now I'm going step by step just to make it very clear. So root 2 times root 3 is root 2 times 3 minus 1 root 2. Because both of them are under roots, but 1 is outside, so you have this. Then here you have 2 times root 4, that's 2. Okay, I guess I should do the same here. So this is like 2 root 2 times root 2, that's 2 root 2 times 2. Okay, and then that is 2 root 4, if you like. And then this is root 6 minus root 2 all over 2. Root 4 is 2. All right. So that is root 6 minus root 2 all over 4. And then that is the answer in a very tidy form. That's the answer in its very tidy form. Now, normally, so for you to check if this is correct, you can just quickly punch your calculator for sine 15 degrees. You just want to confirm that sine 15 degrees is the same thing as root 6 minus root 2 all over 4. So punch your calculator for sine 15 degrees, keep the answer, then check root 6 minus root 2, all of that divided by 4. The answer should be the same. So, but I mean, this is a very beautiful way of expressing that answer if you want things to come in short form. Okay. All right. So let's go to show now. In the second example, um, example 2. Example 2. So we want to show that tan 45 degrees, tan 45 degrees plus A is equal to 1 plus tan A over 1 minus tan A. So that's what we have to show next. All right. Okay. So in this case, right, it means you want to start from here and end up here. So let's go. We have tan 45 degrees plus A. Normally, we know that tan A plus B, we can use that idea of tan A plus B. You know that tan A plus B, right, is the same thing as tan A plus tan B all over 1 minus tan A tan B. So here we have tan 45 plus A. So that means we have tan 45 degrees plus tan A all over 1, because this is plus, we have minus down here. 1 minus tan 45 degrees tan A. Okay? So from the idea of special angles, right, we already know that tan 45 degrees, we know that tan, okay, this is an aside, so let me do that. So recall from the idea of special angles in one of the previous videos that tan 45 degrees is equal to 1. We did that already. Yeah, tan 45 degrees is equal to 1, of course. So from there, we can get back and say that tan 45 degrees plus A is equal to tan 45 is 1 plus tan A all over 1 minus tan 45 degrees is 1 times tan A again, that right there. And then that is equal to 1 plus tan A all over 1 minus tan A. And that is what we are required to show. Okay? So that is the second example. So let's take, okay, should I do all of this? Let me see what I need to do. Okay, I have 3 other examples to go. You know what? I'm going to take one of them, and then you'll take 2 as assignment. Okay? Take 2 as assignment. So let me do one more. Let me do an example 3, and then I'll give the rest as some kind of practice for you. So let's take example 3. example 3. Okay. Let me make a choice. Let me make a choice. Let me make a choice. Okay, yeah, let's do this. Let's go this way. So in example 3 now, we want to show to show that P plus Q plus R is equal to 45 degrees if if tan P if tan P is equal to 1 over 2, tan Q is equal to 1 over 5, and tan R is equal to 1 over 8. So that's what we need to show. So in this case, of course, look at this part. We want to show that P plus Q plus R is 45 degrees. And how do you show that? Now you can see all of this is in terms of tan, right? Tan P is 1 over 2, tan Q is 1 over 5, and tan R is 1 over 8. So what you can do there is to see what happens. You have, so you can say tan P plus Q plus R is equal to so at the end of the day, you just want to show that P plus Q plus R is equal to 45 degrees. So if we start with tan, of course, since everything is tan here, right, we can work with that. So if we say tan P plus Q plus R, you want to try to get that out. So if you follow all the process, right? Okay, well, maybe I should just let me go through the whole trouble, maybe. Let me go through that. So normally, right, you can pull this in two. You can say this is tan, you can say this is tan P plus Q plus R, right? You can have this. All right. So if you have that, that's the same thing as sine P plus Q plus R. Okay. And that is over cos P plus Q plus R. Okay. So if you do it this way, right, the next thing we're going to have is, that is sine P cos Q plus R. Okay. Plus cos P sine Q plus R, like that, all over here. You have cos P cos Q plus R minus sine P. So we just follow the rules we know. So sine P sine Q plus R. So this is what you have for now, right? So the next thing is you want to, okay, let me move it closer to this place because we need a lot of space. So we are still talking about tan P plus Q plus R now. So you see we have sine P already sorted. But then let's look at the whole Q plus R thing. So it means that here now you have sine P times cos Q plus R. Cos Q plus R is actually um cos Q plus R is actually okay, let me see what we are going to end up getting. Yeah, let's keep moving. So sine P, right? Cos Q plus R is actually cos. Okay, we can put this. We have cos Q cos R minus sine Q sine R. That's for this part now, cos Q plus R. Talking about cos A plus B. So that's cos Q cos R minus sine Q sine R. And then you come here and you have so let me take it up. Maybe okay, I think it's better to have it down here. So you now have cos P into sine Q plus R. That is sine Q sine R minus, oh, sorry, not sine Q sine R, sine Q cos R plus cos Q cos R, like that. Okay. So, cos P is out here already. So, but sine Q plus R is sine Q cos R plus cos, cos, Q sine R. Okay, yeah, I think I got that wrong. That's cos Q sine R. It's looking a bit messy. So this is cos Q cos R minus sine Q sine R. Here it's sine Q cos R plus cos Q sine R. Okay, so that's for the top. For the numerator now, we have so we can have cos P down here into cos Q cos R. Cos Q cos R again is cos Q cos R minus sine Q sine R. So that goes for this. And then down here you have minus sine P into minus sine P into sine Q plus R. That should be sine Q again cos R minus sine minus minus so this is plus, right? So sine Q cos R plus plus cos Q cos Q sine R. So with that now, we can have so we can try to tidy things up a little bit, and then we have tan P plus Q plus R, and that is equal to sine P cos Q cos R minus sine P sine Q sine R. That is sine P multiplying this and then this in turn. Then I want to bring this other side down. So cos P going that way. So you have a plus cos P sine Q cos P sine Q cos R. And then the other part now, don't take the mistake. This is just something under. So cos P now. So you have plus cos P plus cos P cos Q sine R, cos P cos Q sine R, cos P sine Q cos R was what we had up here. So we go down again and we have cos P cos Q cos R minus cos P sine Q sine R up there. And then here now we have okay, let me bring it down. So minus sine P sine Q cos R. And lastly, minus times plus is minus. So minus sine P cos Q sine R. Okay, it's always, so now we need to tidy things up. We need everything in terms of sign. So let me change the marker. So it's better to divide by cos all the way so we can make sure everything turns out being in terms of tan. So now we have tan P plus Q plus R, and that is sine P cos Q cos R all over cos P cos Q cos R. That's for this. The second one is sine P sine Q sine R all over cos P cos Q cos R. That's up there. And then we have the next one plus cos P sine Q cos R all over cos P cos Q cos R. And then we're still at the top. That can get really tricky. Yeah. So then we have cos P cos Q sine R, cos P cos Q sine R all over cos P cos Q cos R. All of this again divided by the first one, cos P cos Q cos R all over cos P cos Q cos R. And then we have this next one, minus cos P sine Q sine R. minus cos P sine Q sine R minus cos P sine Q sine R, and all of that divided by cos P cos Q cos R. And then we have the other two, minus sine P sine Q cos R minus sine P cos Q sine R, right? Minus cos P sine Q. Oh, minus cos P sine Q cos R minus cos P minus cos P. This one, yeah, minus. Okay, we've done cos sine sine. Now it's sine cos sine cos. So that's minus sine P sine Q cos R divided by cos P cos Q cos R. All right. And then lastly, we have sine cosine. So minus sine P cos Q sine R sine cos sine all over cos P cos Q cos R. Next, we expected this lengthy thing, but I mean, it's cool if you can just follow it through. Okay, let me change markers here. So now we have tan P plus Q plus R. Now everything is going to be in terms of tan. So let's see how that works. So here you have cos Q canceling, cos R canceling. So we have sine over cos, that is tan P there already. And then here we have, okay, we're still here. What cancels here? Um, okay, like nothing is canceling, I think. Nothing is canceling here. So we have sine over cos. That's tan P, tan Q, tan R. Tan P, tan Q, tan R. Plus, is that plus there? It's minus. Minus tan P, tan Q, tan R. Tan P, tan Q, tan R. Like that. Okay. We have minus tan P, tan Q, tan R. I have that. And the next thing is here cos cancel, cos cos P, cos R. Then we have sine Q sine Q, cos Q. So that is plus tan Q. That's plus tan Q. If you like, that sounds like tan Q. So lastly there, we have cos P canceling cos P, cos Q canceling cos Q, and we have sine R over cos R. That is plus tan R, plus tan R. Okay, things are looking prettier now. So we have this all over, of course, all this cancel everything. So we have one right there. And then we come here, cos P cancels cos P, and then we have sine Q sine R over cos Q cos R. So that'll be tan Q tan R. That's minus tan Q tan R, right? And then we come here, cos R cancels cos R. So we have sine P sine Q over cos P cos Q. So that's minus tan P tan Q. And then lastly, we have here cos Q cancels cos Q. So we have sine P cos P sine R cos R. So that is minus tan P tan R minus tan P tan R. Okay. So I mean, just to make things look a bit neater, so I can just tidy things up. I mean, we've got everything in terms of tan and constant now. So we have tan Q. I mean, tan P plus Q plus R is equal to, so we have that tan P, if you like, plus tan Q, then plus tan R, then minus tan P, tan Q, tan R. I mean, some finicky touch right there, some perfectionistic um behavior. I mean, just to make things look orderly. So here we have one, then tan P tan Q. So we have minus tan P tan Q. Actually, this is not necessary, but I mean, I'm just trying to add some fine is. So tan P tan Q, then we can go minus tan P tan R, minus tan P tan R. And lastly, we can do Q and R, minus tan Q tan R, tan Q tan R. So with this, don't forget where we started from. We're told from the beginning, right, that tan P, we remember, okay, since this is like an aside, if you like, so don't forget that we have okay, maybe I can say recall that tan P is 1 over 2, tan Q is 1 over 5, tan R is 1 over 8. Okay, so the final showdown, if you like, is this. So that's tan P plus Q plus R. So we can fix up these values now. Tan P, we're told, is 1 over 2. Then tan Q is 1 over 5. Tan R is 1 over 8. So we have to sum these three up. Then minus tan P, tan Q, tan R. So we'll multiply them. So we have 1 over 2 times 1 over 5 times 1 over 8 up there. And then we come down here and see what we get. We have 1 minus tan P plus tan Q. Tan P plus tan Q, that's half times 1 over 5 minus not tan P plus tan Q, that's tan P times tan Q. Then tan P tan R, that is 1 over 2 times 1 over 8. And lastly, we have tan Q tan R, that is 1 over 5 times 1 over 8. Okay, so that means that tan P plus Q plus R now is equal to, if we add up all of these things, right? The LCM of 2, 5, and 8 seems to be 40. I believe that's 40. So 2 in 40 is 20. 20 times 1, you have that. 5 in 40, that's 8 times 1, 8. 8 in 40, that's 5 there. So for this now, we have this. We have this here minus. So again, if you multiply out all of this, you have 1 over 2 times 5, 10. All right, 10 times 8 is 80. So you have 1 over 80 for the other side. And then you have, here you have 1, if you like, 1 over 1 minus 1 over 10. Okay, well, I mean, we can leave that out straight. Okay, well, let's just do that. 1 over 10, then this is 1 over 16. That's 1 times 1, 2 times 8. Then minus 1 over 40. 1 over 40. So we have this to be equal to 20 plus 8 is 28 plus 5. That is 33. 33 up there. 3, 3. Okay. Well, something else we can do is this. We can, okay, well, let me just keep going. Let me keep going, no problems. So this is 33. We have 33 over 40 minus 1 over 80. Then this is 1 over 1 minus 1 over 10 minus 1 over 16 minus 1 over 40. You know what I like to do here? Instead of going through all the stress, one thing I like to do is multiply each term by the LCM, and I can see the LCM is 80. So I think that's a very smart way of doing it instead of having to do the whole trouble and adding and subtracting and everything. So you have 33 over 40 multiplied by 80, that goes 1 over 80 multiplied by 80, settled. Then you have 1 times 80 down here, 1 over 1 times 80, 1 over 10 times 80, 1 over 16 times 80, and lastly, 1 over 40 times 80. So if we tidy that up, right, we have, so 40 here is 1, 40 here is 2. So 33 times 2, that's 66, minus 80 times 80, that's 1, right? Right there. So this is now 80 minus 8, 10 here, 10 here, that's 8. 16 here, 1, 16 here is 5. Right? So that's minus 5. And then 48 on 48 is 2. So that's minus 2. So if you tidy that up, 66 minus 1 is 65. 80 minus 8 is 72. 72 minus 5. 72 minus 5 is 72 minus 5 is 67. 67 minus 2 is 65. So interestingly, it means that remember where we're coming from. It means that tan P plus Q plus R is 65 over 65, meaning that tan P plus Q plus R is equal to 1. And then that means that P plus Q plus R is the inverse tan, the arctan of 1. And don't forget, tan 45 degrees is 1. So that means the inverse tan of, so this is what I mean. If I might just quickly go to that. Don't forget that tan 45 degrees is 1. So that means if you take the arctan of both sides, right? Arctan of tan 45 degrees is arctan of 1. So tan cancels out. So that means that arctan of 1 is 45 degrees. So that means that that means P plus Q plus R is equal to 45 degrees. And I think that is where the question started from. So the process has been a very tortuous one because we had to go through all the steps. So you can see we have confirmed that P plus Q plus R is actually 45 degrees. That's a very long journey, but I mean, the logic is important. All right. So at this point, let me give you two questions to practice. So try your hands and be sure you get the gist. Practice questions, like I like to call them, practice questions. Okay, so the first one, of course, from everything we've done, you want to be able to tackle this without stress. So let me give you the first, which is this: show. You want to show that show that cos theta plus cos phi squared. Okay, let me bring it down so I can have enough space to write everything out. Show that, show that cos theta plus cos phi all squared is equal, okay, then plus, plus sine theta plus sine phi all squared is equal to this simple expression, 2 plus 2 cos theta minus phi. So you're going to use addition and subtraction formula here, those things you have done. So of course, naturally, the first thing you want to do is to expand all this and begin to put things together and tidy them up until you get this. Let me write this properly. So you want to have this like this. So that's the first question. Okay. I think I need to take care of this properly also. So show that cos theta plus cos phi all squared plus sine theta plus sine phi all squared is equal to 2 plus cos theta minus phi. So you're going to apply this idea of sum and difference formula. Then number 2 is something very close to this the lengthy question I just answered. So, and that is this. You want to show that tan A plus B plus C is equal to, show that tan A plus B plus C is equal to tan A plus tan B plus tan C minus tan A, tan B, tan C all over 1 minus tan A, tan B minus tan B minus tan A, tan C, tan A, tan C, then minus tan B, tan C, minus tan B, tan C. That is exactly the process I went through before I substituted values in the last example. So it's exactly the same question with that. So you want to check this out. So, I mean, this is how it's been today. So go through again and be sure you really understand all of these things. If you have not subscribed to this channel, be sure to do that. Hit the notification bell so you can always get alerted when a new video is released. Of course, comment, share, like, share with others because these ideas are very useful all the time for people who take courses in trigonometry. And of course, there are many other aspects of maths that I have touched and I'll still touch in the future. That'll be very helpful. So, see you in the next video. Thanks for listening.